Well, hello, my friends. We will continue our journey through probability. In this little video, we're going to examine operations on sets. Now, we're going to start with a new definition, and that is the complement of a set. The complement of a set is every element that is not in the set. Now, of course, what we're referring to is every element in the universe that is not in the set, the universe being all objects of interest. We will use these two ways to denote the complement of a set. Primarily in our videos, we will use this because it is much easier to do on video than S bar. But this SC stands for S complement, or the complement of set S. This also stands for the complement of set S. S complement equals the set of all X such that X is an element of the universe and X is not an element of S. Again, we would read that as S complement is equal to the set of X such that X is an element of the universe and X is not an element of S. You should be getting these symbols down. They'll grow on you. Now, in order to give you a visual representation of this, we'll draw a Venn diagram. In the Venn diagram, we have the universe of interest represented by the letter omega. We also have the set S. Now, S complement is everything in the universe that is not in S. What's that again? Here's S complement. S complement is the set of all X such that X is an element of the universe and X is not an element of S. Should be getting this down. Now, we will start with some other terms. We have S complement. Now we will talk about the union of two sets. The union of two sets is every element in either set. It is represented symbolically by this. This statement is A union B. A union B, that's how it's read. Now, what it could mean as union is also read sometimes as or. A or B, A union B, that means every element that is in A or in set B. And it may be read as A or B. So a union means it's in one set or it's in the other set. Let us begin with two sets, A and B. We have set A, we have set B. The union of A and B is everything that is in A or that is in B. A union B is equal to the set of all X such that X is an element of A or X is an element of B. X is an element of A or X is an element of B. Now, another term we need to know is that of intersection. The intersection of two sets is every element that may be found in the first set and is also found in the second set. It's read with these symbols, A intersect B, read as A intersect B, and the intersect sign can also be read as the word and. The union is the word or, the intersect is the word and. This means it is in set A and it's in set B. A intersect B means it's in A and it is in set B. And again, it may be read as A and B. You're probably catching on that there are two very neat things going on here. We have the symbol of union and intersection, and then we have the words or and the word and. Those will be very powerful words for us. Here's a visual view of A intersect B. It's these elements that are in A and these elements that are also in B. A intersect B is equal to the set of all X such that X is an element of A and X is an element of B. Isn't it neat when you start being able to read these symbols? The union of many sets can be found. We can find the union of two sets. We could find the union of 100 sets. Might even have the union of an infinite number of sets. So we need a symbology to represent this. This following symbol is the union of 5 sets. The union of sets going from 1 to 5. And the union from n equals 1 to 5 of S sub n is equal to the union of set 1, union to set 2, union set 3, union set 4, union set 5. Similarly, we could have an infinite number of unions. This is the union of sets S as n goes from 1 to infinity. The union of many sets can be found. The union of infinite number of sets. Now here's an intersection of many sets. The intersection of many sets, and this is the intersection of 5 sets, very similar to the way we would write union, but this is the intersection as it goes from 1 to 5 of S sub n, so that's the intersection of set 1 with set 2, intersected set 3, intersected set 4, intersected set 5. And here's the symbology for the intersection of an infinite number of sets. Very cool. Now, here's another term. We've met the term union, we've met the term intersection, and we've also found the complement of a set. 2 sets are said to be disjoint if they have no common elements. A is disjoint to B if and only if A intersect B is the empty set. This means that their intersection has nothing in it. They have nothing in common. And that is read as A is disjoint to B if and only if A intersect B equals the empty set. Here's a picture of 2 disjoint sets, and their intersection is the empty set. Here's set C, set D. They have no overlap, therefore they have nothing in common. Their intersection is the empty set, so they are said to be disjoint. Sets A and B are not disjoint because they have some elements that they share in common. A collection of sets is said to be a partition of S if the sets in the collection are disjoint and their union is S. Now let's talk about this. This means that the sets are disjoint, they are in S, and their union is S. Another way of saying that is they have nothing in common with each other, but collectively they make up everything in S. Therefore, they would then be said to be a partition of S. Let's look at this thing more carefully with a Venn diagram. This is an example of a partition of set S. Bear with me. We have sets A, B, and C. Notice that these sets are disjoint, they have nothing in common, and together collectively they make up everything in set S. Therefore, A, B, and C are said to be a partition of S. Sets A, B, and C partition set S. Some of the symbols you need to know from this video. You need to know the symbol for complement, which can either be S complement, SC, or this means S complement. And depending upon the discipline that you study, you may use one or the other of these symbols. But in our videos, we will use S complement since this is easier to construct in text than this is. This means union. This means intersection. Remember that the union is everything in one set or the other. The intersection is something must be in the first set and in the second set. Some of the terms that you need to know. The complement of a set. Complement of a set is every element in the universe that is not in the set. The union of a set means it's in the first one or it's in the second one. Intersection means it's in the first one and in the second one. Disjoint means that the sets have nothing in common, that their intersection is the empty set. Partition means that that the sets are disjoint, and yet collectively their union makes up the entire set of interest. Again, I want to thank you very much for your support. Your watching these videos keeps me employed, and by keeping me employed, you keep me from starving to death. In the mantra of the Hunger Games, may the odds be ever in your favor.